We got some really interesting source material here. Basically, a request to create a script for a deep dive like this one.
Mm-hmm.
And it immediately, kind of surprisingly, connects advanced math, think differentiation, integration with, well, food security.
Yeah, that's quite a leap on the surface, but the source really zooms in specifically on pH sensitivity and fermentation processes.
Yeah.
That's the core thing it highlights within food security.
Right, and the task in the source was clear. Explain this connection, make it engaging, especially for college students.
So that's our mission for this deep dive then. Following the source's lead, exploring that maybe unexpected intersection.
Exactly, how these different fields, math and food science, really collide. And focusing on that pH thing in fermentation, like the source wants. Why is math apparently so key to understanding its sensitivity?
Well, let's break it down. The source names the two big topics: calculus level math, specifically diff and int, and then food security.
Which is huge, obviously.
It is. But the source doesn't just leave it there, floating. It ties them immediately to a very specific practical problem.
Which is that pH sensitivity during fermentation. You know, if you've ever tried making yogurt or sauerkraut or even just getting a sourdough starter going,
Oh, yeah.
you get a feel for it.
Yeah.
pH isn't just some number you check at the end. It drives the whole thing.
Totally. It decides which microbes thrive, which enzymes work. It impacts texture, flavor.
And safety. Crucially, keeping the bad bugs out.
Right, inhibiting pathogens. But like you were hinting, it's not just where the pH ends up. The source seems focused on how it gets there, the dynamics.
Okay, so that's the math link the source is implicitly making.
I think so. Differentiation, in calculus, it's fundamentally about rates of change, how fast something is changing at a specific instant.
And in fermentation, the pH isn't static, is it? It's dropping as the microbes produce acids.
Exactly. So differentiation lets us calculate the rate of that pH drop. Like, how fast is it changing right now?
Okay, but why focus on the rate? Why is the sensitivity to that rate, as the source puts it, so important?
Well, think about it. The speed of that pH change has a direct effect on everything happening in there. The microbes, the chemistry.
Okay, so too fast is bad.
Could be. Too fast might shock the good bacteria you want, maybe kill them off too early. You get incomplete fermentation, maybe off flavors.
And too slow.
Too slow leaves the door open for spoilage organisms, or worse, pathogens, to get a foothold before the environment becomes acidic enough to stop them. So that sensitivity the source mentions, it means the final outcome really hinges on that rate of change.
A small change in speed could lead to a totally different result, maybe even unsafe.
Precisely. So differentiation helps you analyze how quickly that pH is moving at any point. You see the dynamics, the vulnerable points.
It's like looking at the slope of the pH graph over time. A steep slope means something very different biologically than a shallow one.
Right. And while you could use integration maybe to figure out the total acid produced over time, the source's real emphasis on sensitivity points straight to analyzing the rate. That's differentiation.
Gotcha. And there's another layer the source material adds, right?
Yeah.
About the context.
Yeah, it mentions the challenge. Explaining this specific connection, abstract math, food science, pH sensitivity to college students, and doing it quickly, like 3 or 4 minutes.
Makes sense. It forces you to be crystal clear, get right to the point about why it matters in the real world.
Yeah.
It's kind of a communication challenge in itself.
Definitely. So the big takeaway from the source, I think, is this really specific kind of powerful example
Yeah.
that these math concepts like differentiation for rates of change, they aren't just theory. They have real vital uses, like managing fermentation, which is, fundamental to food security worldwide.
It really shows you that complex math and science are often working away under the surface of everyday things.
Yeah, hiding in plain sight, really.
Which, thinking about what this source prompted,
Mm-hmm.
it makes you wonder, where else are these kinds of complex academic ideas shaping your daily life without you even realizing it?